So the warm-up says, find the slope of the line containing the points below. Your simplified answer should be an integer or a fraction. And number one, we have a graph. What is it that we need to be thinking about or using whenever we're finding slope from a graph? Rise over run, right? So we want to be thinking rise over run. And if you'll remember, in my conversations with you yesterday, there are certain things even within rise and run that I want you to kind of keep in mind. The rise can be a rise up or a rise down. It can be rise up or rise down. The run, however, is always to the right. Always. Okay? Which means the run has to begin where? On the left. And if we're only moving to the right, we have to start on the left. And that's a very important thing to understand. So here we go. So we're going to start finding our slope. When we get a graph, what's the first thing we need to identify? Points. We have to find two good points. And if you look at this graph, 0, 0 is going to be one of my two. Now, some of you may have chosen points somewhere else. Someone chose, but I would have chosen 0, 0 because it starts at the origin. And it looks like my next point would be right there, right? Now, as we're measuring rise over run, where do we always start? On the left. So we're going to first make the decision, are we going to rise up or rise down? Are we rising up or down? Up. How many? 30. Because what's the other thing you really need to keep in mind when you're doing rise over run? The scale, yeah, the labels on the X and the Y axis are very, very important. Make sure you're paying attention. We call it the scale of the graph. Because the scale of the graph we can change, just to kind of trip you up. So if you rise 30, so that puts 30 in the rise spot, what is the run? 1. Is 1. It's basically half of 2. So we ran 30, we rose 1, which makes our slope 30. Very good. Which makes our slope 30. Now, did anybody choose different points? And then I'll get your question.
Yeah.
Did you get the same thing?
Yes.
Yeah. Doesn't matter where you are, whether you're doing long rises and runs or short rises and runs, you should always get the same slope because the slope is constant. Muhammad, what was your question?
It's not question. I forgot to do rise over run, and I saw where 1 was on the x-axis. And I saw it was 30, so I put that.
Okay, and it's basically the same kind of concept, right? And the key to keep in mind is that we're always measuring the changes in Y over the changes in X. Remember, the Y-axis is your vertical, and the X-axis is your horizontal. Any questions on this? Okay, so how do we find slope from a table? How do we find slope from a table? Spencer? Changing Y over changing X. Give me 1 second, Mr. Gordon. Changing Y over changing X. So what must we measure first? Remember, I want you, until I've told you until I've told you you don't have to do it anymore, I want you to find the changes every single time. I want you to find the changes every single time. Now, did anyone start doing this?
Yes.
Okay, and what did you get every time? 1. But then when you get to the other side, we end up with this garbage. Minus 0.25. Did anybody write your slope as negative 0.25 over 1? Every one of you would have encountered wrong. Raise their hand. You have to turn it into a reasonable. Now, here's what I would have done. Anybody not do that and do something different? Anybody not go by ones? Watch. I would have done this. How do you get from negative 2 to positive 2? How would you get from 5 to 4? Which makes my slope negative 1/4.
Is it okay when you saw negative? That's what I did. I said that.
Yeah. Guys, what I'm getting at is if slope is constant, and it doesn't matter on a graph which point you choose, it doesn't matter on a table either. I'm sticking with integers. If there are fractions, I stay away from them. If there are decimals, I stay away from them. I pick integers and measure the rise over the run or the change in Y over change in X. It'll get it right every single time. Okay? Everybody good? All right, hold 2 seconds.
Declining as it goes down, right?
Yeah, and that's another thing. Yeah, so this is a declining line, right? But understand that you may never, by the way, this does have a name, just so you know. You might remember what that is called. Think about it. You learned it in 6th and 7th grade. This has a name. It's not the slope. This is the slope. Negative 1/4. It's the unit rate. If it's actually not, but that's when it's taught by some, anyway, that's not. Unit rate is not the slope. But you need to understand that on some word problems, if they ask you for the unit rate, this would not be the unit rate. This would be the unit rate, because the unit rate is always out of 1. The unit rate is always out of 1. Okay? And you'll find on some slope tests, they will sometimes, and they may do it on the EOC as well at the end of the year, they may, instead of asking for the slope, ask you for the unit rate. You need to make sure that you can find that. Okay? So, one way and we put up here the way that this can check. How can you check graph to make sure that you get the rise over run correctly? Because I can tell you, as personally, I always screw up rise over run, or at least enough that it messes with my grade. So what you could do is you could just put ordered pairs there from your graph: 0, 0, 130, and 260. And if you prefer changing y over changing x, you can then check the change in the y over the change in the x to make sure that the slope that you got from the graph is correct. And you can do the same thing, by the way, when you're graphing a line. You simply pick the points. Now, how many points do you need to graph a line? 2. So looking at that table, the 2 I'm choosing are negative 2, 1, 2, 3, 4, 5, and 2, 1, 2, 3, 4. Those are the 2 that I'm picking.
So changing y and changing x and rise over run are the same thing?
They are. Changing y over changing x is the same as rise over run. And remember, because the change in y, which one's the y-axis? The y-axis is your vertical axis. And the x-axis is your horizontal axis. One allows you to check it visually, and one allows you to check it from a table. Slope from a graph, slope from a table. Same thing, so. Everybody good? All right, so today we are going to start to use the slope formula. Now, for those of you that still use your notebooks, on the first or second day, we taped in the formula sheet on like page 2 or 3 of your notebooks. And if you look on that formula sheet, which is the same formula sheet you'll get for the EOC, you'll see under linear equations, the equation for slope of a line. And the equation for the slope of a line is that m equals y2 minus y1 over x2 minus x1. That is the slope formula. That's what we're going to practice today. It's actually fairly simple as long as you understand a couple things. Number one. No, it's on your sheet. It's there. It's on your formula sheet itself. You don't have to memorize anything. It's on your formula sheet. Yeah. No. I'll be done very quickly. The x1, the y1, the x2, and the y2 are simply variables that represent ordered pairs. The x1 and the y1, the x2 and the y2 are simply points, variables that represent ordered pairs. What it's basically telling you, the slope formula is used when you have 2 ordered pairs, and those ordered pairs are x1, y1, and x2, y2. Those are your 2 ordered pairs. The first xy, which is x1, y1, and the second xy, which is x2, y2. That's why you have little sub 1s and sub 2s, just so you can differentiate between your first order pair and your second order pair. Now, once you understand that, every single time you do this, I want to be real clear, every single time you do this, at least on the first couple days homework, you will label your ordered pairs. So the first thing you have to do is label your ordered pairs. So you have to pick one that's x1 and y1, and you have to pick one that's x2 and y2, and I want you to label them right above the ordered pairs. Then you're going to rewrite the slope formula, but you're going to take out the variables and replace them with what? open parentheses. That's the way we substitute. Remember with the equations, when you pull out a variable and you're going to put in a number, I wanted you to pull out the variable and put in open parentheses. You are going to write this every time, just like this. And then you're simply going to follow the formula. What goes in the first open parentheses on the top according to the formula? -6, because that is your y2. And your y1 is 4. Your x2 is 6, and your x1 is -9. Now, the reason we do this with parentheses is that at this point, if your computation skills suck, which some of them do, then you can pick up a calculator and type in the numerator exactly as it's written with parentheses and everything, and it will do the math for you. Now, you don't do the divided by. You find the numerator and you find the denominator. Because I don't want a decimal. Yeah, I don't want to know the division. I want to know the ratio. I want to know the slope. So what is -6 minus 4? -10. Now, you don't have to do that if you're good with the negatives, but some of you have struggled with negatives the entire time. So it allows you to use the calculator if you wish. And what is 6 minus -9? It is absolutely positive 15. Good choice, Danny. I'd get a calculator, son. Because minus a negative becomes addition. Minus a negative becomes addition. Okay? Now again, if you picked up a calculator and done parentheses 6, close parentheses, minus parentheses, -9, close parentheses, hit enter, it'll give you 15. Kennedy.
I like running.
Okay.
Keep track.
Okay.
Not you. Never mind.
So here we go. So what is -10 over 15 simplified to? -2/3. Now, that is the slope. Now, before we go on, I want to talk to you really quickly, because now is where I need you to start being able to form a mental picture in your head. Number one, what do we know about the line that's -2/3? What does it look like?
It's going down.
It's decreasing. Lines are one of 4 things. They're either horizontal, vertical, increasing, or decreasing. And we know that if it's a negative slope, it's a decreasing line, but I want more than that. I want you to start placing a picture as to whether it's a steep line or a flat line. I want you to start forming a mental picture of what the line looks like, and here's how you do it. You start with any point. It doesn't matter where it is. I'm not even going to put it on a coordinate grid. Okay? I can make it difficult for the ones listening. Here's our point. From there, to get to the next point, what are we going to do? Down 2 over 3. We're going to go down 2 over 3. So this is about where the next point would be. Then we're going to go down 2 and go over 3 again. Now, the reason I want you to do that is because, would you consider this line to be a flat line or a steep line? It's not. It's flat, and I'll tell you why. The way you determine steepness versus flatness, if it is running more than it is rising, it's a flat line. If it is rising more, I'll get you in a second. If it is rising more than it is running, it is considered a steep line. So in your head, think about that. If you're going up 8 over 3, that line looks like this. That's a very steep line. If you're going up 1 over 10, it's a very flat line. So in your heads, I'm going to start asking you questions about not just is it increasing or decreasing, because that's good enough for Fabian and Dowd and all the other schools, but it's not good enough for us. I want you to start to determine relative steepness in your heads. I need you to start forming mental pictures of lines based solely off the slope. Okay? You can't have a negative denominator because we only run to the right. Yeah. And if you do math in enter, it'll never give you a negative denominator ever. Okay? So we would call this a decreasing flat line. A decreasing flat line. Spencer?
So if the run is higher than the rise, then it's flat line?
Yeah, because think about it. If the run, watch, if you're going up 2 over 5, this is your line. It's a flat line. See what I'm saying? So if you run more than you rise, it's flat. If you rise more than you run, it's steep. All right, try to find the slope on the second one. Before you even put pen to paper, you better label those ordered pairs. X1, Y1, X2, Y2, please. Label your ordered pairs. Then plug them into the appropriate place based off of the formula. And then do the math. Take your time and make sure when you get into the computation that if you need to use the calculator, you do.
Got it.
About another 30 seconds. Make sure it's a simplified slope. Yeah, X1, Y1, X1. Okay, so really quickly, what did y'all get for the slope?
1/3.
Okay, so we'll assume it's 1/3, but I want you to watch something before we get going. Now here's the interesting thing. It doesn't matter which ordered pair you label what. This is what I want you to watch. I would assume most of you labeled this X1, Y1, X2, Y2. I'm going to go the opposite. I'm going to do X2, Y2, and X1, Y1. Because it's, watch. As long as you put the X1 with the Y1 and the X2 with the Y2, watch what happens. So it's Y2 minus Y1 over X2 minus X1. Now what is 3 minus 5?
Did you do that backwards?
And what is negative 1 minus 5? What is negative 2 divided by negative 6? I did, Kennedy, my point, if you don't remember at the beginning, was, just listen, it doesn't matter which ordered pair you label as X1, Y1, and which one you order as X2, Y2. You will always get the same slope.
As long as you match the X's.
As long as the X1 is with the Y1 and the X2 is with the Y2. As long as they match. What can you tell me about that slope? Is it increasing or decreasing? It's increasing, flat or steep? Flat.
I'm at flat.
Because it's going up 1 over 3. Up 1 over 3. Try another. X1, Y1. X2, Y2. Plug them in for me real quick. Ah, but I won't get caught up. Yelling hush. We just got to come by it before we got to your ground. Now, what you should have gotten is, what you must follow the formula. Every time. You must label the ordered pairs. Every time. And if you did, you should have gotten 0 over negative 7.
I did label it. I just put the 11 on the top.
Then you didn't follow the formula.
I did label it though.
Glad. Now you got to actually use the labels. Now, here's what we talked about yesterday. There was that little weird thing that Miss Earl used to talk about. You can never divide by 0, but it's okay if 0 is in the numerator. And the reason that works is if you put this in the calculator, you get an error message. If you put this in the calculator, you get 0 as the answer. So when the 0's in the numerator, the slope is 0, which means it's what kind of a line? It is a horizontal line. Horizontal line. Yeah, Frank. Well, you didn't yet.
I was.
Okay, hey, really quickly. Brandon was saying, everyone listen up. Brandon was saying he thought you couldn't have a negative negative denominator. You can never have a negative denominator in a final answer for me. Well, yeah, if you do math inner, it will move it itself. Because the calculator knows you can never have a negative denominator. Okay? If you have a negative over a negative, when you simplify it, it becomes a positive. But don't ever give me an answer with a negative in the denominator. Ever. Not a final answer. Okay? Any questions on that?
I was
Yes, Vince.
gone yesterday, so if the 0 is on the denominator, what do we put?
Undefined. It's an undefined slope.
Okay.
If the 0 is in the denominator, which gives you an error message on the calculator, it is an undefined slope, which means it is a vertical line.
What if you have Jonas this?
You won't.
And for,
There is no.
Like, 0 on the top and 0 on the bottom?
Because you'd be finding the slope between the exact same 2 points, and they won't do that. Yeah, well, no, truly, if you think about mathematically, the only way that happens is if the x's and the y's are both the same, which means you're finding the slope between 1 point. You can't do that. Okay? Yes, sir. No, you would say it's a vertical line. Hey, that's one other thing. Listen up. Brandon said, does that mean if you have a vertical line, you have a steep slope? You would think that, but you don't. You would say you have a vertical slope. There is a difference. Steep is a slant. Steepness and flatness are a description of a slant. Vertical is vertical. Okay? Horizontal is horizontal. Okay? All right. So, tell you what, y'all do 5.
I did 4.
I will do, I know, that's why I just said y'all do 5. I will do 6. Because I figured y'all were working ahead. What?
I did help on number 4.
Did you, if I come over there, have you labeled your ordered pairs? Have you written the parentheses, minus parentheses, over parentheses, minus, because if I don't see that, I'm walking away. So I don't really want to waste the walk. I said do that every time. It's the formula. Yes, sir. Guys, you must follow the steps. You must label your ordered pairs. You must do the parentheses, minus parentheses, over parentheses, minus parentheses, which is the formula. And then you must substitute in. Every time. What? Did you do 5? I don't want to do 4. I'll do it in a second.
I got the answer.
No. No.
By the way, do not abbreviate undefined. Okay? Number 6.
you just write so fast, you make it look like it's so easy and I did all this.
He's been doing it all day.
Kennedy, did you get negative 14 over negative 4?
I'm doing number 6 right now.
I'm saying on number 4.
On number, what?
On number,
14 over, yeah.
so then you type that in the calculator, it should tell you it's 7 over 2.
But if you divide that by 2, it's
Nope.
a negative by a positive, you get a negative. Oh my god. I was doing negative 14 divided by 2 to get negative 7 and doing this extra about it. Whoops.
That's what keeps me in business. All right, so here's what you're going to do. These are your reminders. If you weren't with us yesterday because you were taking the test, these are your remembers. These are your remembers for how to describe the slope of a line with regard to the slope, zero slope and undefined slope. When you set them up as a fraction, this will tell you whether or not they are undefined or zero.
No and okay.
This is a vertical, this is a horizontal. You cannot divide by zero. Now, you have classwork and homework, okay? So do your classwork, check it against the key, get on your homework, you should be able to get done. Yeah, Kennedy?
You said remembers. That said reminders. What is
Yeah.